Hello, welcome to Noise Control and its Management. Today is the third day of the 6th week of this course, and starting from today and the remaining part of the week, what we shall be doing is we will be discussing different types of microphones, and we learn all about microphones, so that at the end of this week, hopefully we should be comfortable in terms of understanding how microphones work and which type of microphone is the most suitable microphone for my particular necessity, which may vary from person to person. So, that is the agenda for remaining part of this week, and before we start discussing microphones, quickly we will talk about three types of noise sources. So, there are several types of noise sources, but a lot of times we encounter some special types of noise sources. So, the first type we have already discussed is a point source. A point source. So, what do we have here? We have a point which acts as a monopole and it emits sound in all directions, and when I say all directions, it is in all the three directions, and if it is a perfect point source, then this type of a noise source will emit noise uniformly in all the directions. So, if I have a point, so what is special about a point source? So, based on the mathematics of point sources or monopoles, which we have already done, we know that suppose there are two concentric circles and the point source is located at the center of these two circles or spheres in this case. Let us say this distance is r, and I know that this is not the right scale, but let us say that this is 2r. So, let us say that I am measuring noise level at a distance r away from the center where the point source or the monopole is located, and let us say the pressure is LP, sound pressure level is LP. So, LP is sound pressure level at distance r from the source. Then the question is, what would be this LP prime? So, the question is, what is LP prime, where LP prime corresponds to sound pressure level at distance 2r from the source. And based on the mathematics which we have already discussed in last several lectures, we can say, because it is a spherically symmetric source, essentially there will be a loss of 6 decibels. So, LP prime will be LP minus 6 decibels. So, each time for a point source you double the distance, your sound pressure level falls by 6 decibels. Okay. So, if I make it 4R, then it will be LP minus 12 decibels. If I make it 6R, it will be LP minus 18 decibels, and so on and so forth. So, this is a characteristic about point sources, which are ideal point sources. Next, we will look at line sources. So, the second type of sources we are going to discuss are line sources. Now, you may wonder what kind of a source of noise is there when I talk about line sources. Consider a straight road, and there are lots of cars running on the straight road in a line, linear fashion. So, this entire thing acts as a line source. The sound is being emitted across the length of the line. Okay. So, let us make a picture. So, this is the road, and I have all the sources, these red rectangles, you can think of them as cars. And theoretically, they should be at 0 distance away from each other. Okay. So, these gaps should not exist, and each the intensity of sound coming from each car should be the same. So, if all these things were to be true, then if I draw a cylinder, okay, and let us say the radius of this cylinder is r. So, it is same thing here, and I can draw another cylinder with a larger radius. So, let us say this is 2r. Then I will ask again the same question, that if LP is the sound pressure level in decibels at a distance r from the axis of the cylinder, from the axis of the cylinder, then the question is, what is LP prime? Where LP prime is corresponds to a cylindrical surface which is 2r distance away from its axis. Okay. Its radius with respect to its axis is 2r. So, in a spherical system, you know that it falls by 6 decibels. In this case, and it will be important that if you use principles of energy, basically the energy which is being flowing across a spherical surface, a cylindrical surface of r will be same as that which flows across a cylindrical surface which is 2r in radius. So, if you use that notion that energy flowing across both these cylinders is same, you will find out that LP prime equals LP minus 3 decibels. So, for line sources, each time you double the distance, your sound pressure level it falls by 3 decibels. And finally, we have a planar source. So, we have a point source. So, these are 3 special cases of sound sources: a point source, a line source, and a planar source. So, we will talk about planar sources. So, what is a planar source? Here a sound is being emitted by a plane and it moves in a direction normal to the plane. Okay. So, an example would be, you have a long tube. Okay. Now, this tube could have a circular cross section or a rectangular cross section or whatever, but at one end of the tube you have a piston, and let us say there are no reflections happening in this case. So, this is a planar source. The piston is a surface and the sound which is being produced is being produced by that whole surface, right. So, it is a planar source, and let us say at a distance r. So, this distance is r, and this distance is another r. So, here the sound pressure level is LP. Then if the sound pressure level here, the question is what is LP prime. So, based on what we have understood earlier, and because there is no energy loss and the cross sectional area does not change with respect to r, LP prime equals LP. Okay. So, what we have discussed are these three special sources of sound, and it is important to talk about those before we start talking about noise measurement and all that, because if you have in your situation one of these three types of sources, then each time you double the mic distance between the microphone and the source, either the sound pressure level will fall by 6 decibels or 3 decibels, or it may not fall at all. So, you may want to have this understanding before you start taking a lot of measurements, because then it may give you some idea whether your measurements make sense or not. So, now we will start discussing about microphones. So, we will start discussing about microphones, and what we will talk about is first what we will do is we will classify microphones, and you can classify microphones in several ways. So, the first classification is by measuring principle. Okay, the measuring principle. This is one way to classify microphones, and based on what is the fundamental principle which a microphone uses to measure sound pressure level. So, if I have to classify microphones according to this by measuring principle, I will make a chart. So, we will say microphones, and actually we will describe these different measurement principles. Broadly speaking, we have 6 categories. We have 6 categories. So, in the first category we use these are resistive microphones. What they do here is they use the principle of resistance, where resistance connects voltage and current V equals IR. So, we measure changes in resistance, and from that we try to figure out what is the value of pressure due to sound. So, these are resistive microphones. Then we have different types of capacitive microphones. So, here what we try to do is measure changes in capacitance, and we will describe each of these microphones and their different subcategories. Then we have inductive microphones. So, here we are trying to measure changes in inductance through measurement of some other parameters. Okay. So, that is inductive microphones. And then there are some materials, when you apply external pressure on them, they generate internal voltage. So, these are known as piezoelectric materials. So, microphones which employ the piezoelectric effect, they are known as piezoelectric microphones. Then we have fiber optic microphones. Fiber optic microphones, and then finally we have MEMS based microphones. So, in fiber optic we use principles of light and how light interacts with vibrating surfaces, and based on that we use these microphones. So, what we will do is we will go one by one, especially on the first 5 types of microphones, so that you have a good understanding of what kind of microphones are there in the world and which particular microphone is most suitable for your needs. So, it is important to have that understanding. So, this is the first way to classify microphones. So, we will start by discussing resistive microphones. Resistive mics. Now, these were perhaps the earliest microphones developed by human beings. Okay. So, one person who made these microphones was Edison, and he developed it in 1877, and in parallel another person by the name Hughes, he was in England, he also developed a similar microphone, but he developed a little later compared to Edison, but he had no knowledge of Edison, that Edison had already developed it. So, these were all independent works. Okay. Now, the way resistive microphone works is, so before I talk about how it works, there are two broad categories of resistive microphones. One is known as carbon microphones and the other one is liquid microphone. So, as the name suggests, in the first case we use graphite particles to measure changes in resistance, and in the other case we use liquids to measure changes in resistance. So, we will discuss this carbon microphone. So, it was this carbon microphone which was discovered by or invented by these two guys. The liquid microphone was made by another inventor, Bell, Alexander Graham Bell. Okay. So, he made this microphone. So, let us understand how a carbon microphone works. So, what a carbon microphone has is essentially two metallic plates or surfaces, if you may, and then you have this end is closed and this end, let us say I have a very light diaphragm, very light diaphragm. So, it is in green. So, it has the flexibility to move in and out. Okay. And inside this gap, so this is a metal plate, this is another metal plate, and here I can apply some, I can apply some voltage. So, this is a very crude demonstration, and inside I have loosely packed graphite particles. So, I do not pack them very tightly, they are loosely packed. So, graphite is a form of carbon which has the ability to conduct electricity. Okay. Now, what happens is that when sound hits this diaphragm, it pushes it inside, and so because of the changing sound pressure level here, which is P, which is a function of T, this green thing, the green diaphragm moves in and out, and as the diaphragm moves in, the resistance of this graphite material, it becomes less because the spacing between the graphite particles becomes less, and as the diaphragm moves out, it becomes more. So, as a consequence, the resistance here, resistance starts changing with time, and that is somewhat proportional to changes in pressure. Okay. So, what people do is they try to measure the current, and from the current they try to figure out how much R is changing, and from that they try to figure out what is the pressure, they based on some calibration methods. So, this is a resistive type of microphone, and these microphones were actually very popular in earlier days, and by earlier I do not mean 100 years back, but even like 30 years back, they were used very extensively in our old type of telephones. Okay. So, in old type of telephones, you had a cradle where you would have a microphone and a speaker. The microphone actually worked on the basis of this resistive principle. Okay. And the other place where these microphones used to be used were in radio stations, where they would have these microphones in front of the speaker, and they were used very extensively. So, now they have given way and we use other types of microphones. So, they were very popular microphones. So, this is about the carbon. The liquid microphone is somewhat similar, it is somewhat similar, and what you have there is basically a cup filled with some water with some sulfuric acid, and the purpose of sulfuric acid, it makes water conductive, and then there would be a needle which would be slightly dipping into the water, very small amount it goes into the water, and when sound strikes the surface of water, it vibrates. The water top surface of water is curved because of the surface tension, and it moves up and down. As it moves up and down, the depth of the needle which it is into water, it changes. Because of that, the overall resistance of the system changes. So, that is how this liquid microphone used to work. So, that never became very popular, but carbon microphones were very popular. So, that is all about resistive microphones. In the second case, we will discuss about capacitive microphones, and there are actually several types of capacitive microphones. So, but I think we are almost out of time for today, and what we will do tomorrow is we will actually discuss these other types of microphones, so that you get an overall picture of what kind of technologies are there which are available to ensure that we are able to measure sound pressure levels. So, that is what we plan to do tomorrow, and till then have a great day. Bye.